Okay, so welcome to the Node.js Node API team meeting for January 26, 2024. Let me pull up the agenda and share, and we can go from there. Okay, I'm sharing. Share screen. I don't know why this feels different, but okay, share. So first of all, anything new that we want to share about Node API?
Well, it might be not new because the new version of the add-on API was released in the week before the last week. So,
Sure. Yep.
um, and I didn't see any reports regarding the new version. So I'm going to release the major version, which dropped Node.js v16 support
Yeah.
in the next week. And yeah, that's the plan.
So I'm just going to put that in there. Planning to do a December major release next week. Next week, two drops for this 16. Okay, I think that's worth definitely making sure people are aware of in advance. Sounds good. I guess then if I go back to issues, the one at the top was help with SQL Node Lite performance. I know we've had a few discussions in the back. I don't know if anybody else has had a chance to take a look or experiment.
Sorry about that. I didn't have a chance to work on this one.
Yeah, no problem. So I just will check in, leave that there, and if we get a chance, we can comment. I don't think there's any updates on the C language bindings or full coverage for the debug testing. So I think we could then go to stale issues. I don't see anything new there, so I don't think there's any new update on that one. So we might as well dive into the issues in the repo itself. Yes. So I know Gabriel, this is the one you're working on. Last, I think it was just waiting uh changes to percolate in the upstream. So not in the
Yeah,
upstream, but like in the node core.
yeah, yeah. So I worked on this a little bit last night. For some reason, I must have like force pushed or something because like the GitHub workflow changes, which were introducing like a second set of tests against all experimental versions, was not there anymore. So I put that back, and so now it's running with experimental. See, like we have the standard and experimental now.
Yep.
And in 21 against 21 experimental, it's failing because 21 experimental has the no GC stuff. So I found that our use of an API add finalizer in our inline header is problematic because in 21 it expects it to be like a no GCN. And so I need to backtrack from that and see, well, no, I don't need to backtrack. I need to add another if def in the implementation of attached data, which handles the case where, like we already handled the case where it's less than 5, Node API is less than 5, because then we don't have an API add finalizer. So we add like a symbol keyed value to the object and a hidden property and that kind of thing, just to have the finalizer. If it's greater than 5, then we use an API add finalizer because that's when it was added. So now I need to turn that around and say if it's probably less than or equal to the next version, then you do that, and otherwise you use no GC. I'll figure out the if def, but basically there's got to be an if def there. Actually, it's probably going to be experimental and have no GC finalizer. or have no GCN. That's gonna be it for now. And then when we actually release the new Node API, then that if-def is gonna have to change to whatever version that is. And so, yeah.
Okay.
So that's what I'm working on, and that should fix 21.
Is that just a matter of like adapting the code to work with like new APIs, or is it actually revealing like a problem that we had?
Yeah. I think it's revealing a problem because we're passing a non-NodeGC finalizer to an API at finalizer, and so that finalizer could be calling functions that involve the creation of objects and involve heap manipulation. And so now we know that that's happening, and so I'll have to use a function that I implemented on this PR called defer callback, which is basically go via post finalizer. And so that should get us on par with what we had before while still compiling, which is that all our finalizers are asynchronous. And so, yes, that's still not the final goal, which is to have a facility for asynchronous finalizers, but at least we will be on par with what we had before, which is that all our finalizers are deferred.
Okay, but it's not like we found a case where we were running JavaScript when we shouldn't. It's just like
well, so far it didn't matter, right?
Okay.
Right. So far it didn't matter, right? Because we weren't crashing when trying to do that or intentionally crashing. But now that we are intentionally crashing, we know we shouldn't be running JavaScript, and now we're catching that at compile time. So the code needs to be able to deal with that at compile time, and be the next step in this PR.
Yeah, I'm still trying to just like understand did it just catch something that we were trying to help people catch? Like, because, so like in the previous versions of Node API, Node add-on API, were we trying to run JavaScript when we shouldn't have been? Or is it that just like in adapting to the new APIs and stuff, like as that we've introduced the problem and you're fixing the problem we just introduced? That's kind of
Well,
what
I don't think we've caught anything, because then we would have crashed earlier. Although that's not entirely true either, because, well, yeah, we would have crashed. We would have crashed earlier because before I introduced the Node.js change upstream, the check GC access change was already there upstream, and this code did not crash because the tests all passed. So our code is clean, and our code happens to be clean.
Right. Okay. Yeah. No. Okay. Got it. So like, we don't think there is like a latent problem or something like that, but it's
yeah.
I guess it's like, anyway. Yeah. That's all I was asking. So that's answered. Thanks.
Yep.
Okay. So it sounds like that one's moving forward. Is it like, okay, so, but you still have a little bit of work to do to figure out the 21 failures and stuff. And yeah, it's obviously good.
Yeah,
that
actually,
testing. So
actually, the failures in 21 are going to spread to earlier versions too, whenever the Node.js change gets backported. So the way I'm going to fix this is that not only does it work for 21, it works for any situation where you're in experimental. And now that we have the feature flags, I can check that you have the Node.js environment flag. So those cases happen to coincide with 21 now, but this should fix it for all cases, no matter what the version.
Okay, sounds good. So I think, Shenzong, you already mentioned that next week you were planning to do the next December major release. I don't know if there's anything else to chat about on that one.
Well, yeah, I just found that a document on the README might be lengthy for the anyone who are new to Node add-on API, and I'm just planning to cut down the README so that we can provide a more clear path to the how to set up the build and the API documentation. So
Okay.
that's my plan before I'm going to do the release. In particular, I would like to bring it up that we've been renaming our main branch for a while. So I'm just wondering that if it will be okay for me to remove the section before the header part.
This one right here?
Yeah, right.
Right, yeah, I know, yeah. That makes sense to me. Like that's been a long time, so it's no longer really a heads up kind of thing.
Yeah, exactly.
Yeah. Yeah, no, I think
So
yeah, that totally makes sense.
my plan is to remove this part and to move most of the irrelevant part in um m- um it might be not irrelevant, but it might be the introductory part to a separate document, like say in the document in a directory, so that we can highlight the links and the setups in the README, so that we can promote the ClearPath to the people who are new to Udon API.
Yeah, that makes sense. I could almost see like this top level document.
Also, that I'm planning to move the contributor guide to the contributing.md so that we can also cut down the length of the README. It's located at the bottom of this particular section. And the
Right.
testing and the debugging part right about the contributing section.
Yeah, I can see that there's quite a lot of stuff in this. So like it totally makes sense to me to pull out like
Yeah, right.
there could just be like here's the documentation and one link to like another doc that has that. So yeah, no. I don't know if
Yeah,
anybody else has any concerns, but
exactly.
it totally makes sense to me.
Sounds good.
Yeah,
Maybe worth to
that's my
actually
plan
add.
before. Please go ahead.
Oh, I'm sorry. Like I was, yeah, I actually see it. Like I was actually wondering if we can add just more like common information, what is all about. Like yeah, and some useful links. It sounds like a very good idea to kind of refactor the whole this README file. Thank you.
So I may not get your point clearly. Would you mind repeating?
Yeah, I agree with you that a README file should have only some kind of background information, what this is about, and add all those different links. So I guess like people should understand that this specific module, native module, is about C++ wrappers around Node API. Yeah.
Yeah, right. And the introduction of the module and how to use it and the API references, and I believe that's the essential part that we should include in README.
Right. Maybe like small example, something. I don't know.
Yeah, a short example can be good, but I would afraid that it will be verbose to include that in README. But anyway, I'll file a cardan first to reduce the length of the README, and then please submit any suggestion when you have an idea how to make the document more clear.
Yeah, I think it's because we probably have different, like you have developers who want to contribute coming, we have people who want to use it. And if it's just like, hey, here's the intro, and then like here's a link if I'm the one who wants to contribute, great. And here's a different link if I want to use it. Like I can see that helping people who come get to the right place faster than what it does now. So
Yeah,
okay, it
that's
sounds
my
like
plan
everybody's in
before
favor.
Yeah, that's my plan before the major release.
Okay. Sounds good. Anything else on Node add-on API we should chat about before moving on to the core repo? Okay, let's move on over to core. I will do my typical label. And then take it to PR. Okay, so nothing really shows up as new. Is there any of the existing ones that we should chat about this week?
No one has a topic. I have a small topic to discuss. It's something about this. Last time I started to talk about fast API calls, and we have an issue number 33374.
Okay,
It's already closed, but it's maybe kind
okay,
of a good point to start
sure.
discussion.
Let me find that one. Three. So you said 334.
74. 33374.
I was thinking, if I only have 4 digits, it must be really old.
Yes.
Right. Okay. Yeah. So there you go. Yeah.
So technically, it discussed like ECNV 8.3. They landed a new with fast API calls, and even people like in the very end, you see somebody say like, "Oh, can we do it in Node API?"
Right. Okay.
It's kind of so I start to look at it, and thankfully, my understanding of what this fast API does, like we effectively, whenever we register a function, we need to provide typically like 2 different callbacks. One of them will be for fast API calls, and another one will be for slow calls. Slow calls, it's exactly what we have today, right? And fast one, my understanding, will be picked up whenever V8 optimizes JavaScript code. So I think like whenever JavaScript goes through some optimization phase, they actually start to do all these different kind of JITting and compilation, and then can start to call our function. And the whole definition, it's very similar to me to what libFFI does. I know if you guys had the chance to play with libFFI. So
Yes.
effectively, imagine you have a function, like C function, which may have like different parameters. And when you register this function in libFFI, for example, in this fast API call, you effectively need to provide some kind of array of kind of definition of this function. You pretty much say like, okay, my function has, for example, 5 arguments, and type of these arguments, this, and this, right? And my function returns this type. So you providing this middle information, which helps then infrastructure to wire calls internally. So yeah, like it can be different ways we can implement it and address it. One of my concerns that the whole this fast API in some sense is very V8 specific. But I believe even if we do something in Node API which mimics this fast API call, I believe it can be still useful in other scenarios for other functions. So imagine like our typical function call, we typically give a bunch of different parameters, right? Like we can say several arguments. And using this fast API call definitions, we can potentially generate on the fly conversion from these JavaScript parameters to specific C++ parameters. So technically, even maybe some Node API implementation does not have the same as fast API calls as V8 has, we can still provide some value for people who, I mean, for implementations which don't have it. So we can actually do some automatic type of argument conversions, for example.
I think even if it's like, if the implementation is V8 specific, as long as it doesn't leak into the API, that's okay, right? Like, so is this do you think this is gonna require like extra parameters in some of the method calls or extra metadata, or is it really the behind the scenes implementation?
Yeah, it will require on our Node API to have quite a bit new new types, new definitions. So think about what I mentioned. We need to provide some kind of metadata about function signature, effectively.
Right.
Function signature. We need to say, okay, we have, for example, 5 parameters. This is type of parameters, and types. Just to give an idea, it can be some different type of integers. It can be floating numbers. It can be whatever, typed arrays. It can be object. It can be array, like JavaScript array, JavaScript object. So maybe just some raw pointer. Pretty much, it's like libfy, but it's actually very kind of specific to our domain, to JavaScript domain.
Right. So it's not just like, typically if I'm thinking about it, like in Node API, we'll have like in the code, there'll be like an actual C function and it's got its own types. And then we pass like in what we pass we basically bind that, and that's what ends up getting called, but it's more than just extracting those types, because those are probably wrapper. Like one of the parameters to that function is a list of parameters, right? Not the actual. So to make it actually be effective, we need to not call that C function faster. We need to like not pass the parameters in the same way, I think, is maybe what you're saying.
Right, like it will be totally different ways, totally different protocol to call functions.
And let's remember that these functions, the function pointers we receive from the user for this purpose, there is no chance that they will ever call into things that manipulate the heap. So I'm thinking we probably don't even need to pass any kind of environment to them, because they can't use it in that context, right? So in a way, we're basically saying, give me whatever library function you were trying to bind, and here's another way of binding it, where when the function ends up getting called, things are already translated for you into native. You don't need to call like an API get value int or an API get value float, or you don't need to do any of that because the engine is doing that for you. But in exchange, you cannot call an API create object. You cannot call, node API or an API add finalizer. You can't call any of this stuff because it's kind of JavaScript to native, but about as pure and non-attached to the engine as it can get, right?
It's a little bit more complex story. So technically, imagine that from this fast function, if you want to report any type of error, or you want to really do some JavaScript related manipulation, you need to return some special code that you said, oh, I would like to have a slow path. And the register functions, current API, they register 2 different functions. One of them slow, which is like normal function, like as we do today, and another one's fast. So at any point of time, they allow fast function to say at this specific moment, please don't call me, call other guy who can do all this stuff for me.
Oh, I see. Okay, so you can defer to the slow path. Okay, so then you cannot pass the library function directly, even if you describe it. You still need an in-between function that makes this decision before calling the library function. Is that correct?
Right, but the same, it's up to you how you implement it. And also, they said like what we can't do, we can't initiate any call which can cause JavaScript execution, or anything which can do JavaScript heap allocation.
Right.
But other kind of functions available, like for example, in even like very first example they show there, they allow you to look, for example, for some private fields or private properties associated with object. So there are some manipulation with JavaScript object or JavaScript arrays still allowed, as long as they not cause JavaScript calls or JavaScript allocations.
Ooh, that's a very tricky boundary, because I mean, like even property retrieval can cause JavaScript calls because the property may be an accessor, right? So
yes,
yeah, you
But
need
I
to
guess
be there.
that's not like, that's up to the developer to make that decision or not, right?
Right.
So I guess like, some of the things like the parameters, like there's the, I could see this two ways, not having looked at it enough, I don't really know, but like there would be using it to optimize our call flow to get like, JavaScript gets called, we run some code, which ends up then calling the user's code, and that user's code like does like give me the first parameter, give me the second parameter, and those should mostly be like we don't change the like that get args. I don't think we don't change the arg structure that comes in, right? So if you can pass an array and the guarantee is that you don't change that array, those are like the arrays we pass that method should never like should maybe meet those criteria. So like forgetting what the method itself, like the C function does and the specific parameters, I wonder if there's any optimization we can do just in sort of like the infrastructure of doing the transition from JavaScript to C. It then sounds like the contract might have to be, and once you call me, I perhaps run some JavaScript to like get the parameters, but I don't do anything that's going to cause heap allocations, right? We already have that node.js concept now, so maybe like somehow extending it so that like if you've marked your method as that, then if you call any node.js method, it's gonna say nope.
Yeah. I think like we may actually find some cases like when people say, "Oh, it will be safe to call it, but you not allow me to call." So we can, in some sense, may open some Pandora box for all different kind of chain. But I think it will be a good problem to solve to start with. And just to see how this API look like, if you scroll all the way up a bit, there is a link on top which points directly to this header file from V8. Just if you guys.
This one?
Yes.
Okay.
So like, so just can give you idea, like you see it's you can have a fast method. So fast method you see it's just kind of C function which has normal C parameters, and whenever we kind of register it, we create a new template and we have to provide some kind of C function C++ class which effectively creates some all this meta information about our function, what's return types and stuff. And if you scroll a bit down, you can see what a level available, not in comments, but I think it's already in code. You can see different.
And is like, is it really that you're just guaranteeing you're not going to do anything that causes GC, or is it more than that?
Yeah, I think requirements. If you scroll a bit up, it says like two requirements. It's this one, 23, line 23 and 29, right?
Right.
They
Okay.
should not allocate on GC heap, and they should not trigger GC execution. It's pretty much very similar to what we do today with Node.js.
Right.
That's what I believe. As soon as we introduce this concept Node.js, maybe we kind of we should be in a good path to start to implement such other kind of functions like this, supporting this fast API calls, which pretty much abide to the same rules.
Right, because like I'm just thinking like the new API might be just like, instead of creating a function, it's create a node.js function.
Right.
Yeah,
Yeah.
basically.
Right. And then that's not specific to V8. It's like anybody who can take the make the commitment that they're not gonna like or take advantage of the knowledge that this function is not gonna do anything that will cause GC stuff.
I think we have the name for our API. Node API create no GC function.
And then I guess the slow, but it's sort of like, and how does the fallback part work, right? Because it's kind of like, it's like you have to provide two, right? You provide the slow and the fast one always. Is that the?
Not always. If you want to have fallback, I think my understanding that fallback is actually, I don't know. I didn't look into too much details, but
So
Okay.
I mean, to me, logically, it looks like it doesn't look like the slow callback parameter is optional, right? So I think the slow callback would be like your regular normal binding, right? Where you have to like, get how many arguments there are and then assert that there are four. And, then you have to get the type of each argument and you have to assert that they are of the right type. And then finally you make the call to the actual function. That's what the slow callback sounds to me like, but of course I'm not 100% sure. But that makes sense because if the engine decides, oh, I cannot make a fast call because I don't know, my concept is or my context is all wrong, then it calls the regular call.
Yeah, slow callback is exactly the same function as we use today. Like whenever we
Right.
register just today, slow callback is exactly the same.
So, but does
Yes.
it always make the fast callback? And then if the fast callback says no, it then goes back to the slow one?
I don't think that there is a way to say no because look at the signature for the fast method. That looks like a regular C function that could come from any library. So how would it report back?
I guess it's that you need the slow one. Sorry, I get it. Like the slow one is needed because until it
Sometimes you can't.
optimizes, it needs the slow one to make the
Yes,
call.
yeah.
Okay.
Well, please correct me if I'm getting wrong. If I recall correctly, when the JavaScript call the fast API with the wrong data type, it will fall back to the slow one.
Right. Okay. So it's only
Oh
for
yeah.
data types. Yes. Okay. That makes sense.
Yeah, the only call a fast one is then they did optimization. So technically, when at very beginning, I believe it started to call a slow path first. But after the JIT created this typed way, because it also allows us to provide overload. So there is some effectively you can register multiple fast function calls as a part of this.
Right.
That's
For
good.
different parameters.
Right.
Yeah, because JavaScript loves to have like, okay, if type of context equal Boolean, then blah blah blah. Else if it's an object, then blah blah blah. JavaScript loves to do that. So
We don't
it makes
really
sense
do
that you
that.
provide.
In our use case, it's more like we created and tell it the types, right? Don't we?
Yeah. But what I'm saying is that in the JavaScript world, it's common practice
Sure.
to check how many arguments you have, and if you have two, then that means the first one is an object. If you have three, then that means the first one is a Boolean, and they have this like 10-line header at the top that
Yeah.
just kind of juggles the arguments. And so I guess if we have this feature for overloading, then the engine can compile and thereby optimize those call sites for which it has determined that they follow one of the overload signatures.
Right.
So then that kind of gives the impression that you can have a JavaScript-ish looking function, which is really backed by a native function that is able to accommodate multiple ways of calling it, just like regular JavaScript functions are. So it's like an extra feature on top of just, okay, this is the signature. If you call it like that, it's going to be fast, right? It expands it to several, so that they can accommodate to some extent the JavaScript practice of having different looking arguments in different cases, and that being completely accepted practice.
Right. And yeah, and you can still do that, but I suspect it's going to be a less common case. Like if you're writing it in C, it's probably less common that you're going to have like that variability in the parameters.
Yeah. I mean, our existing libraries, right? I mean, I'm sure some of them chose to implement this type juggling at the top of the binding just to mimic the JavaScript practice, right? Even though it's all written in C++. And in this case, they would be able to potentially translate this code to continue to do this type juggling, except now the type juggling is happening in the engine. And
Yeah.
you know, some use cases might map to this new API, which would be great because it would speed them up.
Yeah, okay. And yeah, it's interesting.
Yeah, definitely worth checking out. Like,
And to answer a question, Michael, about how to report fallbacks, like you see, in case if our kind of function wants to use fallbacks, you need to use like special additional parameter with fast API callback options, like line 40 in this what on the screen.
Right.
Have a
Okay.
special options, and through this special parameter, this function can say, "Oh, I would like to use fallback." It's
Right. Okay.
just they implemented through some additional parameter, and also I want to say that. We see like while this function looks like normal C function, but you see whenever we pass in it, we not passing this function directly, but rather we kind of call in this special helper function, which kind of extracts all these parameter types and does all these additional things. So they're showing it kind of how simple to use it, but in fact, if you scroll up a bit, just where
There, I'm going the wrong way. This way?
okay, over here, like you see, this is what they do. They're saying like a V8 C function make, right? And they effectively C function make is the one who actually does all this kind of magic, if you like. So
Right. Okay.
pretty much extracts all these different argument types, extract a return type, and creates this C function structure class, which says like how many arguments we have, what type of arguments and stuff.
Yeah, and that's where it's a bit interesting because so there's this method, right? Which is like there is a C function, but unfortunately, I guess like in Node API, that function is always going to be something where like the parameters are not the parameters. RC function, the parameters are like you're going to get a JavaScript array of arguments and some other things, right?
to me, this fast method, this looks like the method that you are trying to expose to JavaScript.
Yes.
So this fast method is the actual method in the actual library that you're trying to expose, right? And so instead of calling an API create function, passing in your own function pointer in which you accept an API callback info and an end, instead of that, you're passing in the actual library function and all this description about what the library function looks like.
Right.
And I guess
And
your
so
point about it not having an M might make sense then.
exactly, yeah, because I mean the library function doesn't accept an end. This is not this fast method. This isn't a function that the person writes for the purpose of exposing this fast method. This fast method can come from like I don't know image magic or I don't know libvorbis or whatever, you know. And so all you're doing is you're saying, listen, VA, I have this function. This is what it looks like. Please call it for me from JavaScript if you can. If not, here's the regular binding. Call that one.
Right.
It's interesting. Yeah, it's the part that then is like if you can't do anything JavaScript, so I guess, but you can't, right? You're not trigger JavaScript execution, which is like if you're getting a JavaScript object, then yeah, no. So it would just strictly be like, yeah, here's some C code you can run, but you don't get anything beyond the like you don't get any other context. I'm just wondering how useful that's going to be.
If you scroll down a bit, it's a bit more complex because you can actually pass V8 local object or V8 local array as a parameter.
Right. Okay. Right.
So if you scroll down, they have an example in a comment where they show like a class, and this class has a slow and fast method, and you can effectively because you can actually imagine you call a method from the object. So technically, using this V8 local object, you can grab from private field. And if you scroll down a bit in this example, you will see it. So technically, it's become quite useful in this case. So you still can associate some native data with V8 object classes.
Okay, so you still could potentially. The question, like in that context, like we'd be back probably to like you want an env, but you want that, and then you want it to be like a node.js env, right?
Right. So technically, we'll need to have some node.js env operations which would allow us to do some operations like effectively wrapping and unwrapping object. We need to have something like this.
Right. And it's
Yeah.
how do we get that env, like how do we inject the env, right? Because like it's almost like, I think in this case, V8 is going to do all of the marshaling and unmarshaling, which we typically do, and just call the C function directly, right? Like, so it's like we probably still need a wrapper somehow, like.
Yeah, I think for like extracting pointers out of JavaScript objects, I mean, C libraries don't do that, right? So for that, we're going to need a wrapper which doesn't have the usual NAPI and NAPI callback info signature, right?
Yeah, I guess
Yeah,
like
although,
we're gonna
yeah,
have like
sorry, go
different approaches, if you like. Maybe like special parameter. I don't know. It's
Yeah. But the bottom line is, if the like if the C API function that we're trying to expose to JavaScript, if that one accepts something that V8 renders as a JavaScript object, like I don't know, is V8 able to translate, like are you able to express the fact that parameter 1 is a pointer and parameter 2 is an integer to this C function you're trying to expose? Are you able to express the fact that these two parameters together are really an array of integers? Because if you're not, then you need something that'll take a JavaScript array, it'll extract the length, it'll extract the pointer, and then it'll call this function that you're trying to expose. Because this C convention of having one parameter that is a pointer and the second one that is the length, that's something unique to C, right?
right.
And so if you're trying to expose an API like that, I can see how that would be difficult to explain to V8, because all it knows is this parameter is a pointer, this parameter is an integer, but it doesn't know that the integer represents the length of the pointer. So in that case, you do need some kind of in-between function that does some extraction from potentially V8 structures and then calls the function that you're really trying to expose.
But this does show, and I think Vladimir was pointing at it
Yes.
before, like this actually shows, I think, getting the receiver object. So this is like, this is the method on this class, which I think then that's probably similar to what we use to then get to the env and get to all the other stuff, right? So that kind of seems to say we should be able to do what we would need to get any extra context.
Yeah, exactly. Yeah. So there's kind of three levels in my mind. The first level is where V8 can handle everything and it'll call the library function directly. Then there's a second level where V8 cannot call the library function directly, but it can call this in-between function where the user has to do the manipulation and the marshalling in order to translate to the actual library function. And then there's level 3, which is the slow method, which we all know and love, more or less.
But I think we might be able to, like, I'm trying to think about that. Like in Node API, we might be able to have boilerplate stuff that could, like, have templates that could say, here's my C function, and it would convert it into something which we could use as the real function, right? In the C API, I'm not as sure, because we basically want to have them say, I have my C function, but then we need to generate a wrapper function, which is what actually gets registered, right?
That's the thing. As far as I can tell, for the simplest case, where the types, the return type and the parameter types of the C function are such that V8 can handle them directly, for that case, we don't need an in-between function.
Sure. I just think that,
right?
like, in a lot of cases, we'll need we'll need that in-between function.
Yeah, and then the user basically has to provide it looks like 2 of 3, right? Either the direct function, the library function, and the slow fallback, the in-between function, and the slow fallback, right? So either way, the user has to provide 2 callbacks. In the best case scenario, one of the callbacks is just copy the pointer out of the dynamically loaded shared library and pass it to V8. That's the best case scenario. And then V8, because the function signature is such that V8 can call the library function directly. The second scenario, so let's say we have three parameters. We have very fast, moderately fast, and regular, right? And passing a very fast precludes a moderately fast, but always has to have a regular. So our checks at the top of our API are going to be, if really fast equal null, then assert that moderately fast not equal null, and vice versa, right? And then of course assert that fallback is not null, and then if really fast is not null, then create this function template such that you pass only the really fast function and the slow. Otherwise, call this function template with the moderately fast function and the really slow one. And yes, for the moderately fast function, we're going to have an implementation of our own, which translates things from V8 local V8 object to an API value. So there we're going to have our own in between function, and we're gonna have to, interestingly, I'm not sure how we're gonna handle the context, right? So on line 73, that signature, that is that variable, or is it always that signature, right? Because if it's variable, then we're going to have to receive a description of what this fast method looks like. So we're basically going to be doing like a second level of what V8 does in the really fast case in our own implementation. That's what it looks like to me.
Mm-hmm. Okay, well, I think it looks interesting.
There's another thing that I'm thinking, like maybe we don't need to expose the entire functionality. Maybe doing the really super fast API where you can where we just create a structure that provides a description in V8 agnostic terms, and then translates that to a description in V8 specific terms, and then accepts this function pointer, which we now know can be passed directly to V8. Maybe that's the first step, and then adding this ability to manipulate V8 objects while still not going to the slow path. That might be a second iteration, and then we expose this gradually. That's another possibility. Bite off a small chunk at a time.
Yeah, oh yeah, I definitely we don't have to do everything that's available.
Yeah.
But if it was possible to just say, like, instead of new function, to say new GC function. So it's a new node GC function.
Yeah.
And basically hide the rest of it behind that function call. That would be really interesting, right? And like that might not be the fast one. That would be the intermediate case where, like, if say we've got a function and it passes, like, it's got some known parameters. If you could still even use the same node API calls, like get me the first parameter, but it would be smart enough to know that, like, well, no, I'm not getting it the old way. I'm getting it directly. They passed me an int. So when you ask me for parameter 1, I just give you that int versus extracting it. Like, that would be
I see.
really interesting. And because that would let you basically write your one thing. And then, somehow behind the scenes, we could say, like, oh, okay, well, if you told us it's no GC, and I guess it's also like maybe the parameters have to have a certain shape, then we can translate that into one of these fast things and either get it fast or slow and have the node add-on code look the same, but behind the scenes. And the slow one, it just does the regular thing, and the fast one, it actually says, oh, I got the int faster, here it is.
So one interesting thing is, where does it use param in the receive method param? Okay, so I'm trying to figure out this fast method signature on line 73. So the only example here is where it's basically an API unwrap is what it's doing. Or is it? I'm not even sure, because our Vladimir, please remind me. Our wrap implementation does not rely on internal pointers. It relies on private members, right?
Right, right.
So this wouldn't be useful to us. If this is the only thing you can do, which is to get this private pointer out of the receiver object, and you cannot really call any other APIs, then this signature is not useful to us, because you couldn't even call an API unwrap inside one of these functions, because that requires full access to the heap, which you don't have in these fast calls.
Well, is
So
it that we don't have any access to the heap, or is it that we can't allocate on the heap
okay, true, yeah,
and we can't run
yeah,
JavaScript code, right? So that doesn't
yeah.
say we can't at the C level inspect those objects on the heap.
Yes, yes, but what I'm saying is that the native pointer that we store inside the JavaScript object has to be retrieved by means that potentially invoke JavaScript execution, because it's a property retrieval, right? Because we have a private property, like it's basically like a symbol, but entirely inaccessible to JavaScript. But it's still basically a get call to a JavaScript object.
Right,
So
but it's not one that should ever have like a proxy or anything else, right? Like,
yes, you're right, but I'm not sure if the JavaScript engine, if V8 makes that distinction. It's like, okay, it's a property retrieval. That's it. You violated the thing.
Sure.
The fact that it's a private property and it's not accessible to JavaScript, and therefore it couldn't execute JavaScript code, that V8 may or may not be making that distinction in the case of a property retrieval. So if it doesn't right now, then we would have a feature request to V8 saying, yes, fine, I understand that it's a property retrieval, but because the key is a private rather than a symbol or a string, so
right.
please don't assume that JavaScript may be executed.
Yeah.
Okay.
So yeah, I'm not sure how much we can benefit from that in between thing that is able to receive V8 objects.
Yeah, I don't know. I don't know enough to be pessimistic yet, so I'm optimistic.
Okay.
Vladimir might know more.
I think we just should start working and just kind of see where it goes. But I like this idea that Michael said that imagine we have like a new kind of way to register C functions, and
Yeah.
this slow path will just effectively generate it.
If that's possible, that sounds like the nicest user experience anyway, right?
Yeah, okay, I see what you're saying.
Other complexities, but at least we should provide some kind of simple way for people to use. Sounds very exciting to me, honestly.
Right, and that
yeah,
one
yeah,
seems like we're just providing more information, right? Like, instead of just create me a function that can do anything, here's a more constrained function.
Yes.
Okay, JavaScript engine, if you can optimize based on that, great. And we know for V8, we have a specific idea of what we might be able to do to optimize on, but it's not like tied to V8 or anything in that, if that's the API, right?
Right. And technically, this API would help people to call any kind of foreign function interface functions. Like people, imagine somebody has C library, like we discussed, and they can simply through this new APIs, so people able to bind to them effectively.
Yeah, it would definitely reduce the friction.
And let me kind of work on prototype and see how it goes. Like I'm glad that we had this discussion. It's kind of helps a lot actually.
Yeah, get lots of ideas,
awesome.
right? Maybe impractical ideas, but hey.
Yeah, there are some complexity. I'll tell you that, for example, when you do with int64, they currently offer you a choice how you want to represent it, big int, or you want to have as a number. Like it's the API is great. I think it's we should start providing a way for people to start using it.
It would save a heck of a lot of boilerplate code. Like the just to get CB info and then asserting types and all that. that it would completely reduce that. And I'm hoping in as many of the cases as possible.
Yeah, we can
Oh,
do
but-
this magic functions, C++ magic functions, like they provide in this header file. We can do it on top of our C++ node API. So technically,
Yeah,
Right, like
yeah,
that's
yeah.
what I was thinking. It might be that like we offer some basic extension to the C API, but then more magic happens on the C++ side to actually give you that make it usable, right? Like you'd probably never use the C API on its own, but with the C++ one around it, it actually now does something quite interesting.
Now that you mention it, I think I know why they have this second signature where they have like a receiver. That's so you can like declare classes, right? Because classes, they always have like this receiver and you have to retrieve a native pointer and all that. And so in the V8 API, it makes sense that you would use like the internal pointer thing, but we're more generic than that. But just having functions alone is already pretty useful, I think.
right. All right.
Okay. Well, no, a great topic, good discussion. Anything else we should chat about before we close out for this week? Okay, if not, well, thanks for everybody's time. We will see everybody next week and in GitHub between now and then. Thanks. Bye.
All right. Talk to you later. Bye.
Bye.